The rate of forward reaction and the rate of backward reactions are modified to reach the equilibrium. Position of equilibrium will be changed where the stress is getting to minimized. So this is the principle of Le Chatelier's. Wherever the stress is getting minimized, the direction of the reaction will move towards that side. The forward reaction and also the backward reaction or the reverse reaction is going to happen at the same time. Hello everyone, this is Harshita Bhavasar from Vidhyaashram PU College Temple of Excellence. Today I am going to start session 4 from the chapter Chemical Equilibrium. In the last session we have discussed about homogeneous equilibrium and heterogeneous equilibrium and factors affecting the equilibrium constants. In this session we will discuss about factors affecting equilibrium and what is the explanation for ionic equilibrium. First, factors affecting equilibrium, in that Le Chatelier's principle. What is that Le Chatelier's principle and how it is related to factors affecting equilibrium? We'll see. Change of concentrations of reactant and product, change of temperature and change of pressure of an equilibrium system are known as stresses on the system. Okay. One system will be having some temperature, some pressure and some concentration. If we keep on changing these three variables, what will happen? Obviously, the environment of the system will also change. But it will not only change, it will show as a stress on the system. Consider an equilibrium system in which the forward and reverse processes are occurring at the same rate. Same rate means same time. The forward reaction and also the backward reaction or the reverse reaction is going to happen at the same time. Suppose that the system is subjected to a stress. At that time, stress is also been subjected. Then the rates of the opposing reactions may become unequal and the system is disturbed from its state of equilibrium. At the same time, the forward and reverse reactions are going to happen at that time. Stress is also subjected to those kind of reactions. What will happen? The two opposing rates will also become unequal and the system becomes completely disturbed until it reached equilibrium. The system responds by shifting itself to another position of the equilibrium where the rates of the reactions are again equalized. If that is in the case, what will happen? The direction of the reaction shift will by itself. Why it will shift the reaction? Because to attain equilibrium and also its position of the equilibrium will also change. The rate of forward reaction and the rate of backward reactions are modified to reach the equilibrium. Again itself, the reaction, forward reaction and the reverse reaction will get modified because our destination is to reach the equilibrium. So, it will be modified to reach the equilibrium. Next, if the new equilibrium is shifted to the right, then there is an increased concentration of products comparative to reactants. If the new equilibrium is shifted to right, then the concentration of products will be more than reactants. If new equilibrium is shifted to the left, then there is an increase in concentration of reactants comparative to the product. The effect of temperature, pressure and concentration on the position of equilibrium of a reversible reaction can be predicted qualitatively by Le Chatelier's principle. These three variables of a reversible reaction can be qualitatively predicted by this Le Chatelier's principle. The principle states that if an equilibrium system is subject to a stress, then the system will respond by shifting itself to another position of an equilibrium in such a way that effects of stress are minimized. Okay, whenever we are also having some problem, we will reach towards where the problem is get minimized. Like that, whenever the reaction is under more stress, position of equilibrium will be changed where the stress is getting to minimized. So, this is the principle of Le Chatelier. The overall concept of stress on the system and response by the system is, if addition of reactants, equilibrium shift to right. If removal of reactants, shift towards left. Addition of product, shift towards left. Removal of product, shift towards right. Increase of pressure, shift in the direction of decreased number of moles, means where the number of moles is less, then towards that side the equilibrium will shift. Decrease of pressure, shift in the direction of increased number of moles. Increase of temperature, K decreases if delta H decrease than 0, that is exothermic reaction, and K increases if delta H, that is enthalpy, is greater than 0, that is endothermic reaction. When this equilibrium constant decreases, when change in enthalpy is less than 0, this equilibrium constant will increase, change in enthalpy is more than 0, means that will be endothermic and another will be exothermic. You know what is endothermic and endothermic reactions. These are the stress on the system and response by the system. According to Le Chatelier's principle, if a system at equilibrium is subjected to a change of any of the factors such as temperature, pressure or concentration, the system adjusts itself in such a way so as to nullify the effect of that change. That is, the equilibrium system shifts in that direction that tends to undergo the effect of change. This is what the Le Chatelier's principle are going to tell. We know that wherever the stress is getting minimized, the direction of the reaction will move towards that side. How it will be? Stress will be going to happen because of change in temperature, pressure and concentration. Okay. And effect of addition of inert gas. These are the other effects. The response by the system upon the addition of an inert, that is non-reactive gas, to the equilibrium system depends on delta N, difference between the number of moles of products and reactants, and also on whether the addition is made at constant volume or constant pressure. If they are going to add the addition of inert gas, and that overall equilibrium system will depends on delta N, that is difference of number of moles present in product side as well as reactant side, and the addition is made at the constant volume or at constant pressure. When it will be added? At constant volume or constant pressure is present. See here, type of the reaction. This is effect of addition of inert gas to the equilibrium system. In the type 1 reaction, delta N equal to 0, means the moles will be, difference between moles of will be 0. Equilibrium is not affected either at constant pressure or at constant volume. Here equilibrium is not at all disturbed. In type 2, if delta N equal to positive, at constant volume equilibrium is not affected, at constant pressure equilibrium shifts to the right. If number of moles is positive side, then at the constant pressure equilibrium will shift to the right side. For example, PCl5 will decompose this into PCl3 plus Cl2. In the type 3 reaction, delta N equal to negative, at constant volume equilibrium is not affected, at constant pressure equilibrium shift to the left. Okay, N2 plus 3H2 to NH3, that is ammonia. Here at constant pressure equilibrium shift to the left, here at constant pressure equilibrium will shift to the right. But at the both the side volume will not affected. Okay, these are the three types of reaction in effect of addition of inert gas. Next, the equilibrium will be unaffected by the addition of the inert gas, a constant volume process. As I told, addition of inert gas, if we are going to do, constant volume will not affect it. By the addition of an inert gas at constant pressure, equilibrium will be shifted that direction in which there is increase in the number of gaseous moles. Where the gaseous moles are present more, there is the way to have the direction of the equilibrium. Next, effect of adding a catalyst. What will happen if they are adding a catalyst? Addition of a catalyst to a reversible reaction has no effect on the value of equilibrium constant. On the reverse reaction, if the addition of catalyst is going to happen, there will be no effect on the equilibrium constant. It neither changes the reaction quotient nor the equilibrium constant. There is no changes at all, means no changes in reaction quotient also and no reaction at equilibrium constant also. Thus, a catalyst cannot alter the position of equilibrium. it does the change the rates of both forward and reverse reaction to the same extent. Means what is catalyst? It will enhance the rate of a reaction or decreases the rate of a reaction but does not change the position of equilibrium. Here you have to understand, once again I am telling, catalyst will change the rate of a reaction either in a forward reaction or in a backward reaction, but it does not show any changes in position of equilibrium. So it will not affect with equilibrium constant also and also reaction quotient also. Next, relationship between equilibrium constant and standard free energy change. What is that relation? Delta G naught equal to minus 2.303 RT into log Kc. Okay, every constants you know this is standard free energy change and this is minus 2.303. R is gas constant, T is temperature, Kc at different concentrations, equilibrium constant. This relation is known as van 't Hoff reaction isotherm. This relation is very much important and it will be called as van 't Hoff reaction isotherm. If delta G naught is less than 0, then this equilibrium constant will be greater than 1. This means the reaction is spontaneous and that the reaction proceeds in forward direction to such an extent that the products are present predominantly. Means if standard free energy is less than 0, then will be equilibrium constant will be more than 1. The reaction will move in a forward direction and also it will be spontaneous. Another case, if delta G naught is greater than 0, then Kc will be less than 1. This means the reaction proceeds in forward direction only to a small extent and the backward reaction is favored and very minute quantity of products is formed. Here products will be predominantly formed. Here products will be very small quantity will be formed. Seen here forward direction will be started but continued with backward direction. Products will be very less. If delta G equal to 0, then Kc equal to 1. This indicates that both reactants and products are equally favored and reaction has attained equilibrium. Here reactants and products are equally favored. Okay, these are the three cases and also the relationship between the equilibrium constant and the standard free energy. Next, we will see some of the illustrations. Given a reaction A plus B will form 2C plus 3D. 1 mole of each A and B are heated in 2 dm cube container. At equilibrium, 0.5 mole of A was found to remain in the equilibrium mixture. The equilibrium constant for the process in mole per dm cube is, there is options 2.34, 1.6875, 4.96, 0.846. What will be the answer? We will see now. Initial concentration in moles. First in A also 1, in B also 1. Here we are seeing the initial concentrations. So there is no need of writing for the product. Next, number of moles of at equilibrium. Reacted 0.5, 0.5. That is also given in problem itself. Remaining 0.5 and 0.5. Formed how much? 1.0 and 1.5. Volume 2 dm cube. Then concentration of A equal to 0.52 divided by 2. Concentration of B equal to 0.5 divided by 2. Concentration of C 1 by divided by 2. Concentration of D 1 by divided by 2. Means product by reactant. This you know that. Okay, at equilibrium constant, these are the product by reactant. Okay, these are the moles what they have written, and 1 into 3.375 into 4, 4 into 8 into 0.25. At equilibrium constant 1.6875 mole per dm cube. Okay, so what will be the answer? B will be the answer. Next illustration, the volume of the reaction vessel containing an equilibrium mixture in the reaction, that is SO2Cl2, and it will decompose into sulfur dioxide and chlorine, is increased when equilibrium is re-established. what will happen? The amount of sulfur dioxide will decrease, the amount of sulfur dioxide, dichlorine will increase, the amount of chlorine will increase, the amount of chlorine will remain unchanged. What will be there? An increase in volume for the equilibrium having first product divided by reactant, the mole of SO2, mole of chlorine, mole of SO2 Cl2 into volume. Will increase the mole of Cl2 or SO2 to maintain equilibrium constant volume at constant level. Okay. If the volume of Cl2 will increase only, the moles will be keep on increasing. So, the option C is the answer. Next, ionic equilibrium, electrolytes and non-electrolytes. Here you can see a new terminology, that is electrolytes and non-electrolytes. Substance like acids, bases and salts, when fused or dissolved in water, dissociate to form positively charged ions and negatively charged ions, and this phenomenon is called ionization. These substances are called electrolytes as they are able to conduct electricity in the fused state or in the aqueous solution. If you take any acid, base or salt, if you are treating with water, what will happen? It will form positive ions and negative ions. Those ions should conduct electricity. Then it will be called it as electrolytes. Okay. Substances like glucose, urea, sucrose, etc. dissolve in water without ionization, either in the fused state or in aqueous solution. They do not conduct electricity. These are called non-electrolytes. Okay. Some examples like glucose, urea, sucrose, etc. dissolve in water but without ionization. Ionization means the separation of positive ions and negative ions. If the separation is not going to happen, they does not conduct electricity. Only dissolving is not will conduct electricity. Okay. Without, see here, dissolve in water without ionization, it will not conduct electricity, then will be considered as non-electrolytes. This is the difference between electrolytes and non-electrolytes. Once again, substance which will dissolve in water, it should get separated by positive ions and negative ions, then it will conduct electricity, will called electrolytes. If substance is getting dissolved but not get separated with these two ions, will not conduct any electricity, so that will be called it as non-electrolytes. Next one, types of electrolytes. Depending upon the degree of dissociation, electrolytes are classified into two types, that is strong electrolytes and weak electrolytes. Depending upon degree of dissociation, the electrolytes are classified into two types, that is strong electrolytes and weak electrolytes. First we will see strong electrolytes. Electrolytes that undergo almost complete ionization in aqueous solution are called strong electrolytes. Their solutions have high electrical conductivity. Which electrolytes are undergo almost complete ionization to conduct electricity will be called it as strong electrolytes. Example, strong acids like hydrochloric acid, nitric acid, sulfuric acid, like this. Strong base, sodium hydroxide, potassium hydroxide and calcium hydroxide, and salts, sodium chloride, potassium chloride, magnesium sulfate and sodium acetate will also a salt, and most of the examples. These are the explanation of strong electrolytes and its examples. Next we will see weak electrolytes. Electrolytes undergo only partial ionization even in dilute solutions are called weak electrolytes. Partial ionization. Okay. And they have low electrical conductance, increases in dilution, increases in their conductance rapidly. Since the degree of ionization increases with dilution. You know about the dilution and the concentrated solutions. So, whenever dilution of the solutions or substance will keep on increasing, there the conductance will also increases. So, weak acids are carbonic acid, phosphoric acid, hydrogen fluoride and hydrogen cyanide, and in that organic acid, acetic acid and formic acid, etc. Inorganic weak base, ammonium hydroxide, organic base C2H5NH2, that is amine family. These are the explanation for strong electrolytes and weak electrolytes. with their respective examples. Okay. In the next session, we'll discuss what are acids, bases and salts, hydronium and hydroxyl ions, and periodic trends in acidic properties. Next session also very much important to understand the behavior of acid, bases and salts. I hope you have understood completely whatever I have taught today. We'll meet in the next session. Thank you.